You're going to see that side on the monitor.
You remove the mask.
What are you fearing? Because we must. Okay. I'm not seeing myself now. Good morning, students. Okay, so this morning we are going to look at friction. So by definition, friction is a force that opposes relative sliding motion between two surfaces in contact. So the two surfaces must be in contact with one another, and there must be tendency or actual motion between the two surfaces. We have two opposing forces. We have friction and we have resistance. So when we are representing them using a diagram, we must clearly distinguish the two. Friction must be clearly made different from the resistance. So how do we represent friction? So when we draw the two surfaces, we have the body in contact with the other surface. Then we apply a force. Let's say this is force P. The friction is drawn between the surface of the body and the surface of the plane. So the friction is drawn along the two surfaces in contact. So this is the frictional force. This is the applied force. The weight of the body will act vertically downwards, call it W, and then the normal reaction will act vertically upwards, call it R. Okay? So now let's look at a situation whereby in which we apply a varying force to a body which is in contact with a surface, to a situation where there is friction. Okay? So when we apply a varying force to this body, the frictional force will increase accordingly. When force P is 0, the frictional force F is equal to 0. So when we increase P to, for example, 2 Newton, the frictional force will increase accordingly to 2 Newtons. So the frictional force will increase until it attains a maximum value. And this maximum value, we call it F max. We call it F max. It is the maximum friction, beyond which it will not increase. Okay? So the maximum friction between two surfaces in contact is F max. It will not go beyond this value. Okay? Now when the friction is maximum, the body is said to be in a state of a limiting equilibrium. Limiting equilibrium. So this is a state in which the friction is maximum. So the maximum friction in a body is given by F max, is given by mu R, where mu is referred to as the coefficient of friction. Mu is the coefficient of friction. So by definition, it is the ratio of the maximum friction to the normal reaction. Okay? So when the maximum friction is equal to the normal reaction, the coefficient of friction will have a value which is equals to 1. This occurs when the maximum friction is equals to the normal reaction. But in practice, the maximum friction may not be equals to the normal reaction. It is always less than the normal reaction. So this maximum value of mu being equals to 1 is just a theoretical value. Okay? It is not a practical value. Okay? Now when the surface is smooth, when the surface is smooth, for a smooth surface, the coefficient of friction is given a value which is 0. In other words, for a smooth surface, there is no friction. So friction is equals to 0. Now when the surface is rough, for a rough surface, the coefficient of friction is greater than 0 but less than 1. Or we can take the theoretical value that is equals to 1. So for a rough surface, the coefficient of friction is from 0 to 1. Okay? Now when the body is moving across the surface, the coefficient of friction is taken to be maximum. It's taken to be maximum, and it corresponds to the maximum frictional force. Now let's look at one example showing us how we can calculate friction. So let's look at this question, which says that, let me write the question quickly on the board. It says that a body of mass 10 kilograms. Body of mass 10 kilograms is initially at rest. On a rough horizontal surface. On a rough horizontal surface. Full stop. It is pulled along the surface. It is pulled along the surface by a constant force. Constant force of 60 newtons inclined at 60 degrees above the horizontal. Full stop. If the resistance to motion total is 10 newton, if the resistance to motion totals 10 newtons, find the first part of the question saying magnitude of the normal reaction. Part 2 is saying find the acceleration of the body. And then the last part of the question saying you find the distance moved This is moved by the body. By the body. By the body after 3 seconds. So in this case, the first thing we need to do is to read through the question, understand the question, and then translate the question into a diagram. So the question is talking about resistance. Remember I said that we have two opposing forces. We have resistance, we have friction. Friction, I said that it acts between the two surfaces in contact. Resistance acts on one of the body which is moving. Okay? So the question is talking about resistance, so we must indicate resistance instead of friction. So in the working, let's say this is the horizontal surface. So this body of mass 10 kilograms, so let's say this is the body. It is of mass 10 kilograms. So its weight is going to be given by the mass, which is 10 times the acceleration due to gravity, which is 9.8. So this is 98 Newton. The weight of the body is 98 Newton. The normal reaction will be acting vertically upwards. So this is the normal reaction. So the body is being pulled along the surface. So the pull is acting in this direction. So this is the pull, and according to the pull, the question, the pull is of magnitude 60 Newton. So the force which is pulling the body is 60 Newton. And this force is acting at 60 degrees above the horizontal. This is the horizontal. So the angle the force is acting above the horizontal is 60 degrees. Now, according to the question, the total resistance to motion is 10 newtons. Remember, I said this is not friction, it is resistance. So it is drawn above this surface and it must be parallel to the surface. So this is the friction. It is 10 newtons. So this is the diagram showing all the forces acting on the system. Okay? So the first part of the question is saying that we find the value of R, the magnitude of the normal reaction. So we can do this by resolving the forces. So we resolve the forces vertically. When we resolve the forces vertically, we'll find that the vertical component of R is acting upwards. The vertical component of this force is also acting upwards. The vertical component of this force is acting downwards. And this force has no vertical component. So, since the system is in equilibrium, okay, this force plus the vertical component of this force must be equal to this force, which is acting in the opposite direction. So we're going to say that R plus 60 sine of 60 is equals to 98. Okay? Equals to 98. So when we solve this, we get R. We get R to be 46.0385 Newton. So that is the size of the normal reaction. Then the second part is asking us to find the acceleration of the body. The acceleration of the body. So to get the acceleration, we apply Newton's second law. So Newton's second law says that the resultant force F is equals to mass times acceleration. Okay? So the resultant force is given by the difference between the horizontal component of this force, which is pulling the body, and the resistance. So this becomes the accelerating force. So when we resolve the forces horizontally, we are going to say that 60 cosine of 60 minus the resistance is equals to the mass, which is moving, times the acceleration. So this is Newton's second law. So when we calculate this, we get the acceleration as 5 meters per second per second. So this is the acceleration at which the body is moving. Then lastly, part C is saying that we find the distance moved by the body after 3 seconds. Okay? So initially the body was not moving. Okay? The question tells us that a body of mass this is initially at rest on a rough horizontal surface. So that means that the initial speed of the body u is equals to 0. The acceleration of the body A is 5 meters per second squared. The question is asking us to find the distance of the body after time t is 3 seconds. So the question is asking us to find S. So we need an equation which connects all these quantities. Connects U to A, to T, and to S. And the equation is S is equals to UT plus half AT squared. So we just substitute for these quantities. So U is 0, T is equals to 3 plus half times the acceleration, which is 5 times 3 squared. So when we calculate this, we get our S to be 22.5 meters. So this is the distance through which the body moves. Okay? Notice the distance through which the body moves. The second example. I don't know whether I'm very fast. Maybe I can slow down a bit. Okay, so that I give you time to look through the work. Okay, so let's say you are done. Now let's look at the second example. The second example. It says that when a horizontal force, of 28 Newton, horizontal force of 28 Newton is applied to a body of mass 5 kilograms, to a body of mass 5 kilograms, which is resting on a rough horizontal surface. The body is formed. To be in limiting equilibrium. Find the coefficient of friction. Find the coefficient of friction between the body and the plane. Okay. So again, the first thing we need to do is to draw a diagram showing all the forces acting on this body. Okay. So let's say this is the horizontal surface and this is the body. So this body is of mass 5 kilograms. So the weight of the body will be acting vertically downwards. The weight we say is mass times acceleration due to gravity. So it will be 5 times 9.8, which is 49 newtons. The normal reaction will be acting vertically upwards. So this is the normal reaction. The force which is acting on the body, according to the question, is horizontal and it is of magnitude 28 newtons. So let's say this is the force acting on the body. It is horizontal and it is of magnitude 28 newtons. Okay? Now, this body is in a state of limiting equilibrium under this condition. So it means that this body is at the point of sliding across the surface. So the friction between the body and the surface must be maximum. And remember we said that friction must be drawn along the boundary. So our friction is this one here. It must be drawn along the boundary. And this friction is maximum. And we say that the maximum friction is given by mu r. Okay? This is the coefficient of friction times the normal reaction. So the question is asking us to find the value of mu. What is mu equals to? Now, since the body is in a limiting equilibrium, the body is not moving. So the friction is maximum. When we resolve the forces in any direction, the resultant force must be 0. So let's resolve the forces vertically. So when we resolve the forces vertically, we are going to say that R is equals to 49 newtons. This force must be equals to this force. Then when we resolve the forces horizontally, this force must be equals to this force. Remember, the body is in a limiting equilibrium. So mu R is equals to 28 newton. So we can call this equation 1 and call this equation 2. So to determine mu, we eliminate R, or we substitute for R, or we divide the two equations. So dividing equation 2 by equation 1. Dividing equation 2 by equation 1 will give us this mu R over R is equals to 28 out of 49. So the horizontal surface. Horizontal surface. If we can't have horizontal surface. Coefficient of friction. Coefficient of friction. Coefficient of friction. Coefficient of friction. 0.2. 0.2. So the question is saying that we find the distance. Find the distance. The body will move. The body will move. Find the distance the body will move across the rough surface. Across the rough surface before it comes to rest. Before it comes to rest. Before it comes to rest. Okay? So in this case, we need to understand the question very well. Okay? So the question has two situations here. It has the body moving across a smooth surface, and then the body moving across a rough surface. So when the body is moving across the smooth surface, when it is sliding along the smooth surface, there is no resistance to its motion. Okay? The resistance will only exist when the body moves into the rough surface. Okay? So the initial speed of the body just before entering the rough surface is 2 meters per second. So in the working, we are saying that the U, the initial velocity U, is 2 meters per second. Okay? Now when this body enters the rough surface, there is going to be resistance. So that resistance will cause the body to decelerate. Okay? So we need to determine the deceleration. Okay? So we need to determine the deceleration. So the acceleration of the body, we need it. Okay? Then of course the question is saying that we find the distance the body will move across the rough surface before it comes to rest. So when it comes to rest, it means that the final speed of the body is going to be 0. So what is the value of A first? Before we can find the distance S. What is S? Okay? So how do we get the deceleration? So let's say that this is the surface, which is rough. Okay? This is the body which is moving across the rough surface. There is no force moving this body forward. It is moving on its own momentum. Okay? The weight of the body will be acting vertically downwards. So since the mass of the body is 2 kilograms, the weight is 2 times 9.8, which is 19.6 newton. The normal reaction is going to be R. Okay? Now the friction is maximum in this case. So our maximum friction is given by the coefficient of friction times the normal reaction. So this body is moving in this direction, into this acceleration A. So the question is asking us to find the acceleration. Here we get A to be negative 0 point, it's not 0 point, negative 1.96 meters per second squared. So it is a negative because it is a deceleration. Remember, the final velocity of the body is going to be 0. The body will come to rest. Now to get S, we know U, we know A, we know V. So we use the fourth equation for uniformly accelerated motion. So we're going to use V squared is equals to U squared plus 2AS. Our V is 0 is equals to U is 2 plus 2 times the acceleration, which is negative 1.96 times the S. Okay? So when we calculate this, we get S to be equals to the distance across the surface through which the body moves. So the distance is going to be 1.020 meters. That is the distance across the surface. Okay. The next example. Says that a body of mass 100 grams. Body of mass 100 rest on rough horizontal surface. Rest on rough horizontal surface. Rough horizontal surface and has a light string. Light string. That's a light string inclined at 20 degrees. 20 degrees above. 20 degrees above the horizontal. Above the horizontal. Above the horizontal. Attached to it. When the tension in the string, is 0.5 newtons, the body is on the point, of sliding, So the question is saying that find the coefficient, of friction, between the body, and the surface, Okay. So again, the first thing we need to do is to draw a diagram showing all the forces acting on this body. So the body rests on the horizontal surface. Let's say this is the horizontal surface. This is the body. The weight of the body will be acting vertically downwards. And since the mass is 100 grams, the weight is given by the mass in kilograms times the acceleration due to gravity. So the mass of the body is 100 grams, change it into kilograms, then times the acceleration due to gravity. So when you calculate this, you get 0.98 newtons. The normal reaction is in this direction. This is a normal reaction. So this body has a light string inclined at 20 degrees above the horizontal attached to it. So let's say this is the string. It is inclined at 20 degrees. This is 20 degrees above the horizontal. Okay? So the force in the string, according to the question, is 0.5 newtons. So this is 0.5 newtons acting on the body. Okay? Now, since this body is in limiting equilibrium, according to the question, it says that when the tension in the string is 0.5 newtons, the body is on the point of sliding. The body is in limiting equilibrium. The body is about to move. So friction is maximum. So remember we said that the friction must be in between the two surfaces in contact. So friction is this one here. And it is maximum. And the maximum friction is given by mu r. Okay? So the question is asking us to find r. Okay? So how do we get r? We resolve the forces. Horizontally, we resolve the forces vertically and solve for r. So let's resolve the forces vertically. So when we resolve the forces vertically, this is acting vertically upwards. This is acting vertically upwards. This is acting vertically So this force plus this force will be equals to this force. So when we resolve vertically, we get R plus 0.5 sine of 20 is equals to this force, which is 0.98. Okay? Then when we resolve the forces horizontally, this force will be equals to the horizontal component of this. So mu R is equals to 0.5 cosine of 20. So we can call this equation 1, we can call this equation 2. So we just need to solve the two equations simultaneously to determine the value of R. Okay? We need to solve these two equations simultaneously. Alternatively, you can first solve for R in 1 and then substitute for R in 2 and then get the value of mu. Okay? The choice is yours. Okay? So when we solve these two equations simultaneously, we are going to get mu to be equals to 0.3897 when we solve simultaneously. That's what we get. So that is the coefficient of friction between the body and the surface. Okay? Now I have a question here for you, which I'm calling a trial question. Okay? So I want you to write down this question and try it during your free time. It's a very interesting question. You will inbox me your solution. Okay? So the question says that a cake of mass 500 grams lies on a horizontal surface, of a plate, full stop. The coefficient of friction between the cake and the plate is 0.1, full stop. So the question is, will the cake slide across the plate? Will the cake slide across the plate when the plate is moved? When the plate is moved horizontally. With an acceleration of 1.1 meters per second square. Okay, so this is the question. It slide or it will remain stationary as the plate is moving horizontally at that acceleration. Okay, please, I want you to try the question during your free time, and you inbox me the solution. Okay, it requires some simple reasoning. Okay, now let's move on and look at a body which is on an inclined plane. All the three examples we have looked at so far deal with bodies which are on horizontal plane. So when the body is on a rough plane, how do we handle the frictional forces? Okay, so let's consider this body of weight W resting in limiting equilibrium on a rough plane inclined at theta degrees to the horizontal. Okay. So let's look at this body. It has a weight of W and is on a plane which is rough. Remember we said that when the surface is rough, there is friction. So let's say this is the plane which is rough. The angle of inclination here is theta. So this body is resting on that surface. Okay. So the weight of this body, according to the statement, is W. Okay, and it must be acting vertically downwards. The normal reaction will be perpendicular to the plane at the point of contact. So that is the normal reaction between the plane and the body. So if this body is to move, it will move down the plane. Okay, on its own, it will move down the plane. It cannot move up the plane. Okay, so friction opposes that motion. So the frictional force between this body and the plane must be acting up the plane. So our frictional force is going to act in this direction. It is going to be acting up the plane. Now, if this body is in a limiting equilibrium, the frictional force will be maximum. So the maximum frictional force is going to be mu r. Okay. Now we can split this force into two parts. One part perpendicular to the plane, and then the other part along the plane. So this is the part which is perpendicular to the plane. It is W cos of theta. This is the part which is along the plane. It is W sine of theta. Okay. Now for this body to be in a limiting equilibrium, okay, for equilibrium, okay, the forces acting along the plane must balance each other. There must be a balance. Okay, so this force must be equal to this force, and this force must be equal to that force. For the forces acting perpendicular to the plane. So for equilibrium, W sine theta. Okay, W sine theta must be equals to mu r. That is for equilibrium. And then W cos theta must be equals to r. So these are the conditions for the body to be in equilibrium. The component of the weight of the body down the plane must be equals to the maximum frictional force. And then the normal reaction must be equals to the component of the weight of the body perpendicular to the plane. So if we call this equation 1, and we call this equation 2. So equation 1 divided by equation 2 is going Give us W sine theta divided by W cos theta is equals to mu R divided by R. So therefore, tangent of theta is equals to mu. Okay. So in order for equilibrium to exist, the tangent of the angle of inclination must be equals to the coefficient of friction. Okay? Otherwise, if this angle or the tangent of this angle is greater than the coefficient of friction, the body will slide down on its own. And if the tangent of this angle is far, far smaller than the coefficient of friction, the body will not slide. The body will remain at the same position. Okay? Now, for the body to slide, for sliding to take place, for sliding, this force must be bigger than this force. So we're going to say the W sine theta must be bigger than mu R. Okay? It must be bigger than mu R. Or we can say it must be bigger or equal. So let's look at the minimum condition for sliding. Okay? So in order for this to slide, this one must be that. Okay? But of course, this is equals to this. R is equals to W cos theta. So this means that W sine theta must be greater than or equals to mu times W cos theta. Remember, R is W cos theta. So therefore, again, tangent of theta must be greater than or equals to mu. So this is the condition for sliding to take place. Okay? So long as the tangent of the angle of inclination of the plane is greater than or equals to the coefficient of friction, sliding will take place. Okay. So, can I stop? Because I think I have around 9 minutes. You want me to teach up to the end? Now let's look at one example showing us, and this is the last example for the day, showing us how we can do calculations involving friction on an inclined plane. Okay? So the first question is going to deal with resistance. Okay? So the question says that a body of mass 20 kilograms, a body of mass 20 kilograms is released from rest. Is released from rest at the top of a rough slope, which is inclined, at 30 degrees to the horizontal. If the body accelerates down, if the body accelerates down the slope, at 3 meters per second squared, find the resistance resistance to motion. Find the resistance to motion experienced by the body. Experienced by the body. And the magnitude of the normal reaction. The magnitude of the normal reaction between the plane and the body. Okay. So we need to start by drawing a diagram showing all the forces acting on the body. So let's say this is the plane which is inclined at 30 degrees above the horizontal. Okay. Let's say that the body on its way down has reached this point. The weight of the body will be acting vertically downwards. So this is the weight of the body. It is given by the mass of the body times the acceleration due to gravity in newtons. The normal reaction will be perpendicular to the plane at the point of contact. That is the normal reaction. The resistance to the motion of the body will be acting in the direction opposite to the direction of motion. The body is moving down the plane, so the resistance must act up the plane. So let's say that the resistance is Fr. So this body is accelerating down the plane at a rate of 3 meters per second square. Okay? This body was released from rest. So the starting speed here is 0. Okay? The body was released from rest. So the question is saying that we find the resistance to the motion. Now let's split this force into two parts. The first part being along the plane, and the second part being perpendicular to the plane. So we have this component, this is along the plane, this 20 G sine of 30. Then this component, which is perpendicular to the plane, is 20 G cosine of 30. Okay. Now, to find this force, we must apply Newton's second law. The resultant force is equal to the mass, which is moving, times the acceleration. So we can say that by Newton's second law, okay, the resultant force here, since the body is moving down the plane, is given by 20G sine of 30 minus the resistance, which is Fr. So it will be equal to the mass which is moving, and the mass is 20 times the acceleration, which is 3. Now G is the acceleration due to gravity. So we substitute for G. Remember its value is 9.8. So this is going to be 20 times 9.8 sine of 30 minus Fr equals to 60. So when we solve this, we get Fr, the resistance, to be equals to 78. Resistance is going to be 78 newtons. Okay? So having got the resistance, we can now calculate the normal reaction. The question is saying we find the value of R. So we can do that by resolving the forces perpendicular to the plane. So resolving the forces Force is perpendicular. Perpendicular to the plane. Perpendicular to the plane. When we do that, we are going to get R to be equals to this force, which is 20 G cosine of 30. And remember, G is 9.8, so 20 times 9.8 cosine of 30. So when you calculate this, you get your R to be what should be the value of R? Let me try to calculate, but our time is what? Is over. So the value of R, okay, let me give you this figure, but please cross check it. It is 98 point something. Okay, so thank you very much for listening to me. Our time is over, but we have attached the notes, so please read through the notes, redo these questions I've worked out, and also try the questions which I have not done. Thank you very much. Good day. So